Hi, this is your Lucky sir. We are in chemical kinetics topic. This is class 5. In this, we'll discuss about rate law. Rate law is actually when you see a reaction like A plus B gives us to C and D, for example. Here, small a moles of A, small b moles of B are given. The rate is directly proportional to A to the power of some x, B to the power of some y. This expression is called rate law. Or if you remove this proportionality mark, you can take one constant. Rate is equals to k into a to the power of x, b to the power of y. So here we are giving the relation between the rate and concentration terms. That we are saying here the mathematical dependence of the rate of a reaction. The mathematical dependence of the rate of the reaction with the molar concentrations of the reactants. Okay, now how that is depending. That is known as rate law, or you can say rate equation. See, A moles A, B moles B, giving you C moles of C and D moles of D. So rate is proportional to A to the power of X and B to the power of Y. So here you can notice one very important point. Students often get confusion about this. Students get often confusion about this particular point. Here A is there, here some X is mentioned, here B is there, here some Y is there. X may be equal to A or X may not be equal to A. Both conditions are possible. So it need not to be the stoichiometric coefficient. For example, you are taking CH3COO C2H5. It may be 2 moles and you may not get 2 moles in the reaction. This may be sometimes when you are writing the equation CH3COO C2H5 to the power of 1 only. Or sometimes it may be 0. Or sometimes luckily it may be 2 also. So this stoichiometric coefficient and here the power term may be same or may not be same. So here k is rate constant, or is a specific rate. X is order with respect to A, y is order with respect to B, and this expression is called rate law. Rate law is nothing but the relation between rate and concentration terms. Rate is equals to k into a to the power of x, b to the power of y type we can write. So x is order with respect to A, y is order with respect to B, x plus y is the overall order, right? K is specific rate, or is a rate constant. This point is very important. Just now I was explaining this one only. X and y need not be the same as stoichiometric coefficients A and B, right? Coming to the characteristics of rate constant. Rate constant is k, right? Rate is equal to k into concentration of something to the power of x. This is the rate constant, and about the rate constant of a reaction becomes equal to the rate of the reaction when the concentration of all the reactants are unity. That means if it is 1, something to the power of 1, and this is concentration of all the reactants are going to be 1. So 1 to the power of 1, this is nothing but 1, and rate is equals to k. Hence the rate constant is also known as specific reaction rate. Okay, the rate constant will be equal to rate when the concentrations are unity. It does not change with change of concentration of reactants, products, volume of vessel, and coefficients of reactants. For example, rate is equal to k into concentration of some A to the power of 2 or something is there. If you are changing A, this k won't change. Okay, now you may change A, you may change B, or whatever the conditions you want, you can change concentrations and volume, all these you can change. The k is going to be constant. K does not depend on concentration or volume, but k depends on temperature. It depends on temperature according to Arrhenius equation. Arrhenius equation is known to us. K is equal to AE to the power of minus EA by RT. You can check our past class. Or log K2 by K1 is equal to EA by 2.303 R T2 minus T1 by T1 T2. This is the expression that you need. The rate constant of a reaction is always a characteristic value at given temperature. That means at a temperature it is fixed. Okay, now if you change the temperature, it changes. Greater the rate constant, greater will be the rate of reaction, because rate is equal to K into concentration of A to the power x, like that we are writing. So rate is directly proportional to K. If K is greater, rate is also greater. It always increases by addition of catalysts. When rate of reaction increases, automatically K increases. So this point is very interesting. The units of the rate constant of an nth order reaction are, okay, now if nth order reaction means if you are taking A to the power of n like that, then the units are, rate constant units will be liter to the power of n minus 1, mole to the power of 1 minus n per second. For example, if you are taking zero order reaction means rate is equal to K into concentration of A to the power 0. A to the power 0 means this term is only not there. Okay, so rate constant unit, rate units and rate constant units will be same. Rate units are moles per liter per second, and K units will also be same. That is what we are mentioning here. Fine. If it is a first order reaction, here directly second order reaction we event. For example, first order reaction, rate is equal to K into A to the power 1. This is moles per liter per second is equals to K into moles per liter. Concentration is moles per liter. So you can very comfortably cancel this moles per liter. So K units will be per second. Very, very interesting. Now you see, for zero order, moles per liter per second. For second order, third order, you see here liter per liter is there, it will be liter. Here mole is there, it will become per mole. This is second. For second order, liter per mole per second. For third order, liter square per mole square per second. These two became squares. Liter square per mole square per second. Interesting? Okay. The ratio between the rate constants of a reaction at two temperatures which differ by 10 degrees Celsius is called temperature coefficients. Based on this, so many interesting questions will come. Temperature coefficient is equals to K by K. This is at T temperature. This is at T plus 10 degrees Celsius. If you are increasing 10 degrees Celsius, then that particular at that particular temperature and the initial temperature, whatever the rate constants are there, their ratio is known as temperature coefficient. In general, temperature coefficient value is 2 to 3. In general it is 2 to 3. For most of the reactions, the value of the temperature coefficient is found to be 2 to 3. This means that the rate constant of a reaction increases 2 to 3 times with the 10 degrees rise in temperature. So what type of questions can be asked? I will give you one simple example here. For example, at 10 degrees Celsius, rate constant value is, rate constant, I am not saying rate constant, you see, this is 2. And temperature coefficient is again 2. So 10 degrees to 50 degrees, what will be the rate constant, they will ask. So what you need to write is 10 degrees, 20 degrees Celsius, 30 degrees Celsius, 40 degrees Celsius, and 50 degrees Celsius. At 10 degrees Celsius, they mentioned that rate constant is 2. And temperature coefficient is 2 means it will be doubled. So it will become 4, becomes 8, becomes 16, and becomes 32. So these will be your entrance questions. If at 10 degrees Celsius, rate constant is 2, what will be its rate constant? 32 degrees Celsius if temperature coefficient is 2. For example, if temperature coefficient is 3 beta, as 10 degrees Celsius, let us say it is 1, K is equal to 1, what will be at 40 degrees Celsius? And temperature coefficient is 3. So 10 degrees to 20 degrees to 30 degrees to 40 degrees. Okay, this is 30. Fine. So it is mentioned that this is 1 year, K is equal to, it should be tripled, coefficient is 3, so it will become 3. 3 will become 9, 9 will become 27. If at 10 degrees Celsius it is 1, then at 40 degrees Celsius it will be 27. This is about the temperature coefficient. Thank you.